Good evening. For anyone who doesn't know me, I am Rachel Livermore. My background is astrophysics, but obviously I'm also a huge nerd, which is why I'm here. And I've given a lot of talks about how accurate science is in science fiction. And tonight, what I'm going to talk about is, or this afternoon, depending on where you are. At this time, I'm going to talk about how real science has influenced science fiction. And obviously, that is a huge topic that could be an entire convention by itself. And I don't have time to do all of the ways that real science has impacted science fiction. So I'm just going to pick two examples. The two examples that we are going to talk about are, I find my pointers, the renowned science fiction author and feminist Johannes Kepler and famed astronomer J.R.R. Tolkien. Two writers who were very influenced by science in writing science fiction. And I'm going to start by posing a question, which makes me very glad this is an online convention where I can't actually see anyone, so it's not going to trigger a massive argument, because this has been the topic of many an internet argument, and that is, what was the first science fiction novel? Now, depending on who you listen to, you're going to get different answers, and it depends how you define science fiction, how you define novel. And frankly, I don't really care what the answer is, because I think those are meaningless definitions. A common answer you'll get rather, is this one, obviously, Mary Shelley's Frankenstein. If you restrict yourself to the modern novel, and this is often considered the forerunner of science fiction because it has these fantastical events that were triggered by science, not by any kind of magic. But obviously, science fiction stories predate Frankenstein by some way. And if you're having this as an internet argument, the trump card that people like to pull out is this one. Lucian's, it's translated here as True History. It's more often referred to as True Story, written by Lucian of Samosata, not in 1902. That was a translation. It was actually written around the 2nd century CE. But whether you consider this the first science fiction really depends on your definition of science fiction. It's really intended as a satire of like tall tales told by travelers. So the idea is this traveler is telling this ridiculous story that can't possibly be true. And so it involves going to the moon. There's no actual science in it, and therefore definition of science fiction is a little bit shaky. But it does feature the moon quite heavily. No particularly scientific ideas about the moon, but the idea of voyaging to it, which is going to be a staple throughout science fiction history for the next 2 millennia. It's obvious that the moon has inspired a lot of people. It's the most visible thing in the night sky. It's visible for much of the month, and very, very bright, and has obviously caused people to ask a lot of questions, like since antiquity. Another dude who was very interested in the moon, before Lucian even, Plutarch, who lived around the 1st century CE. Greek philosopher, not my area of expertise. I believe he's best known for writing about some Roman dudes. But the writing that I'm particularly interested in is this one, which is On the Face Which Appears on the Orb of the Moon. This is a fascinating piece of work. Kind of philosophy / science, kind of metaphysics / fantasy. It's very interesting as a summary of kind of what was known or thought about the moon at the time. There are some very interesting bits in here that I'm going to pick out, particularly this passage here about the downward tendency of falling bodies proves not that the Earth is in the center of the cosmos, but that those bodies which, when thrust away from the Earth, fall back to her again, have some affinity and cohesion with her. The idea here is we're used to thinking of, pre-17th century, everyone thinking that the Earth was the center of the universe. That's by no means true. Someone else around this same time who was talking about this kind of thing was Aristarchus, who had the idea of the sun as the center of the universe. So this was by no means fixed. But one thing that caused people to have issue with the idea of the sun as the center of the universe is we know that everything on Earth falls towards you in the direction of the center of the Earth. So everything on Earth seems to be held to the Earth. And that makes the idea of the Earth as the center of the universe very appealing, because then everything is drawn towards the Earth. And so if you're going to remove the center of the universe to the sun, then why are we bound to the Earth? It actually makes quite a lot of sense that that was a point of confusion. And why too was the moon not falling down onto the Earth? It was quite apparent to everyone that the moon was pretty close to us. So why did it not fall? What Plutarch says about that is the moon is saved from falling by its very motion and the rapidity of its revolution, just as missiles placed in slings are kept from falling by being whirled around in a circle. For each thing is governed by its natural motion unless it be diverted by something else. That is why the moon is not governed by its weight. The weight has its influence frustrated by the rotary motion. So in these two passages here, you've actually got a pretty solid idea of gravity. So this kind of belies the idea of Newton inventing gravity a millennium and a half later. A lot of the ideas were actually already in place, which is pretty interesting. Now, he also talks a lot about the nature of the moon and the idea that it's a terrestrial body that is kind of rocky, that it has geographical features similar to the Earth, like mountains and valleys. It was thought to be inhabited, possibly, maybe by animals bigger than those on Earth. This is an idea that comes up a lot, not entirely sure why. The fact that it was bright was thought to be because of the Earth, that it gets its light from the Earth. These ideas were not original to Plutarch. He actually attributed them to Pythagoras, aka Triangle Dude. I said he kind of goes off on a kind of metaphysical tangent as well. He talked about the moon as a kind of way station for departed souls from the Earth. We don't need to get into that. But a lot of the ideas of the moon as a terrestrial rocky body, that it's bound to the Earth by gravity, but prevented from falling in because of its motion, a lot of this was in place, in ancient Greece. But when we get to the 16th and 17th centuries, the idea that's kind of taken hold everywhere is that the sun is now the center of the universe, and that the heavens, anything outside of the Earth, are kind of divine and incorruptible. And so the idea of talking about any of these heavenly bodies like the moon as being similar to the Earth was heresy. So this idea kind of drifted out of fashion over the intervening millennium or so. And then we get to the 16th century, and 1543 in particular, the year that Copernicus died, his heliocentric model of the universe was published. And this actually used an idea of gravity that dates back to Plutarch, the idea that everything is drawn towards the sun, but that everything on Earth is governed by the gravity of Earth. So there was no kind of mathematical or physical foundation to this yet, but the basic idea was already there. The modern day narrative, when people talk about Copernicus publishing this heliocentric model, heliocentric just meaning that the sun is in the center, is that it was rejected as heresy and that the church refused it on religious grounds. That isn't actually quite what happened. It wasn't really for religious reasons that Copernicus's ideas were kind of sidelined. They didn't really get a lot of notice at all. And that's because scientifically, this model was not very good. By this point, the geocentric model, this is the model with the Earth at the center, had been modified quite a lot. People like to make fun of Ptolemy's epicycles. This is the idea that you've got the Earth in the center, things are orbiting around the Earth, but they have to go in a kind of spirograph pattern in order to make everything work. This is overly complicated, and this complication was what Copernicus was trying to get around. But his model actually did a worse job than Ptolemy's of predicting where the planets would be at any given time. And so it didn't really make any sense to accept it. Also, if you think about it, the idea that the Earth is moving incredibly quickly to do a full orbit of the sun every year, I mean, surely we would feel that, right? It's not crazy that people were skeptical of the idea that we could be whipping around the sun so quickly and yet have no idea that we were moving. So it wasn't actually really anything to do with the church. Scientists just didn't take a lot of notice of Copernicus, with a few exceptions. A big thing changed a few decades after Copernicus died, when Tycho Brahe spotted this. He didn't actually see this. This is a supernova remnant. What it would have looked like in 1572 is a new star appearing in the sky. So this is where the word nova comes from, new. This was, we now know, a supernova as a star exploding at the end of its life. But at the time, the appearance of a new star threw this whole idea of the heavens as immutable into question. If a new thing can appear, then these stars are not fixed. They're not unchanging. So this caused something of a revolution in the world of astronomy. Here in England, Thomas Digges adapted the Copernican model and just threw all the stars outwards so that instead of being on one fixed sphere, they extend to infinity. Giordano Bruno came up with the idea that all of these other stars are just other suns like our sun, and that they might have other worlds orbiting them. This became known as pluralism and got him burned at the stake. So that was not a popular idea. And this is where Johannes Kepler joins our story. People often describe him as the first astrophysicist, because he was the first one to really apply ideas of mathematics and physics to the model of the universe. And because he gets that designation, people often think of him as a very serious scientist. But actually, even by the standards of his time, his ideas were a little bit wacky. He would have gone in for some of the woo that was in the talk earlier. He was a supporter of Copernicus. He believed that the sun was at the center of the universe, but he didn't think that for scientific reasons. He thought that because the Son of God is the center of Christianity, that the sun had to be the center of the universe. Yeah, it's pretty nuts. He just turned out to be right. That's lucky. And this is why he became obsessed with proving the heliocentric universe. And in the course of that obsession, happened to develop some really useful laws of planetary motion that we're still used today. So that's cool. He also came into contact with Tycho Brahe, the guy I mentioned who observed that supernova earlier. Went to work for Brahe in his 20s. Tycho Brahe was a Danish nobleman. This is back in the days when you had to be rich and given an observatory by a king in order to do science. So Kepler went to work with him. The huge benefit of this was Tycho Brahe had some of the best astronomical observations in the world. And when he died in 1601, Johannes Kepler inherited not only his job as the imperial mathematician to the Holy Roman Emperor, but also all of that data. And it was with that data that he was able to develop his own theory of planetary orbits, which looks something like this. Actually, it doesn't look anything like this. This is a modern version that has way more planets than Kepler knew about. He only knew about planets out as far as Saturn. The big change that Kepler made to the Copernican model, he kept the sun at the center of the universe, but he said, what if the planets are not orbiting in circles, but in ellipses? This made it slightly less perfect. So, people didn't like the idea that the nature wasn't completely perfect, but made all the mathematics work so much better. He still had some kind of wacky ideas, though. If planets are moving in elliptical orbits, this means they're not always the same distance from the sun. And when they're closer to the sun, they move faster. When they're further away, they move more slowly. And this, excuse me, I forgot my point there. If he looked at the ratio of the fastest and slowest speeds of different planets and likened this to music. So if you look at the Earth's orbit is almost circular. So the difference between its fastest and slowest points is not that much. The ratio is about 16 to 15. That happens to correspond to a semitone in music. And so there's this quote from Kepler's book: "The Earth sings mi fa mi. You may infer even from the syllables that that in this our home misery and famine hold sway." Misery and famine being the mi and the fa. So what he was getting at was the idea that everything perfect and divine is up in the heavens, and that Earth is where all the awfulness happens, and that somehow this is reflected in words that we happen to use to represent notes in music. Not entirely clear. For him, his laws of planetary motion were not a mathematical convenience. They were supposed to be a window into the mind of God. So we talk about his laws of planetary motion a lot, but one thing that we don't really talk about very often is that Kepler was also fascinated with the moon. He also thought of it as terrestrial. This was very heretical in his time, but as we've discussed, the idea does date back to ancient Greece. He thought that it was rocky, that it had terrain much like the Earth. Copernicus also thought the moon was likely terrestrial, because he thought it had to have something in common with the Earth, because the moon orbited the Earth, whereas everything else orbited the sun. Kepler took that further and said that the moon influenced the tides through magnetic fields. I don't think he meant magnetic fields in the sense that we use the term today. He meant some kind of force at a distance, which is exactly true. That's what gravity is. And he thought that for the moon to exert so much influence over the Earth, that it had to be very similar. So jumping back a little bit, back in 1593, when Kepler was a student, he'd written this dissertation defending Copernican cosmology. And in this, he talked about how beings on the moon might view the Earth. So this is actually the foundation of a lot of science fiction, right? The idea that you take a scientific idea and then use fiction to discuss how that idea would actually affect people and how they see the universe. That's the very first science fiction that I ever read was Nightfall by Isaac Asimov. And that's the thing that hooked me on science fiction, was you can take an idea like a planet with many suns and not talk about it just in scientific terms, but in terms of how would that actually impact the lives and the experience of people who live on that planet. So that's what Kepler was doing in his dissertation. And he was using it to defend Copernican cosmology by saying that if you were on the moon, we know that the moon orbits the Earth. That's never been doubted. But if you were on the moon, you would also be moving with the moon. And so you would perceive that as being stationary. And you would look back at the Earth and say, well, obviously the Earth is moving. And if any of the beings on Earth denied that they were moving, you would think they were ridiculous. In the same way that if we look at beings on the moon and see them deny that they're moving, we would think they were ridiculous. So this was actually a very interesting essay. It didn't go down terribly well, though. It was not a popular idea. And so sometime later, when he revisited this idea, he revised it to introduce the element of a story. His idea was to fictionalize it by pretending that the whole moon thing was a dream, that someone had fallen asleep. It's an astronomy student, in fact, in the story, falls asleep and dreams of these demons on the moon who live there and who are able to transport him up to the moon. So it's obviously very fantastical, but it does contain real science, including the then very controversial theory that the sun was the center of the solar system, and that the Earth is actually moving and that movement is invisible to us. So this was in 1608, we believe, that he wrote this. And this is right around the time that this dude, Galileo, was using his telescope. There's a common misconception that Galileo invented the telescope, In fact, he never even claimed that that was the case. But he did correspond with Kepler quite a lot. And honestly, I could give an entire talk just about the correspondence between Kepler and Galileo because it's fascinating. One of the things he wrote to Kepler was that he believed that the Copernican system was true, but he was too afraid to say so publicly. This is quite early on, of course. He did later go on to say it publicly, and that didn't go so well for him. But in 1610, he published this, usually referred to in English as either the Sidereal Message or Starry Messenger, which contained some of his observations with his telescope and had three main findings. The one that people talk about the most is the discovery of moons around Jupiter. So this is his diagram. The big O in the center is Jupiter. The little asterisks are the moons of Jupiter, and he saw them always in a line, but changing their position night by night. This is a more modern picture, of course, not to scale. This was a really profound discovery because this showed that there were these other bodies, in this case the moons, that were orbiting a whole other thing, that were completely indifferent to the existence of the Earth. As far as these moons are concerned, Jupiter is the center of their universe. And this is quite a profound discovery if you're not even quite comfortable with challenging the idea of Earth as the center of the universe. So this is the one that gets talked about the most. There was some other stuff in this book. Lots of stars. If you use a telescope, you can see many more stars than are visible with the naked eye. He showed that there are at least 10 times more than you can see with the naked eye. This diagram here, I believe, is the Pleiades. I've kind of oriented that so that it kind of looks like his diagram. But the one that I'm interested in for these purposes is his observations of the moon. He was able with his telescope to see the moon in a lot more detail than anyone else ever had. And these are some of the drawings he took. And what he found was that the moon is not a perfect sphere, that it has all these imperfections. People had already seen that it had dark and light patches, but he saw them in a lot more detail and was really able to see that the moon does have terrain, much like Earth, that it has mountains and valleys and craters. He didn't quite interpret it like that, though. He actually thought that the dark spots were the sea and the brighter regions are land, which is not a crazy idea if you're just seeing this through a primitive telescope. Kepler had actually written previously that this was the other way round, but became convinced that Galileo was right. So this work was hugely controversial at the time that it was published. And a lot of people were afraid to publicly support it. So one person who did publicly support him was Johannes Kepler, who wrote quite a lengthy response to this. He was the one who named it the Starry Messenger, which is a whole other story that was really unfortunate. And the church ended up seizing on that translation of the name to imply that Galileo thought he was actually getting a message directly from God, which was not anything that he ever claimed. But Kepler was actually very, very pro Galileo's work. And in fact, he's quite effusive in his letters. And he actually wrote to Galileo intending that this should be made public. That he said, if you deem this letter of mine worthy of display, it may bring you this advantage against the obstinate critics of innovation, for whom anything unfamiliar is unbelievable, for whom anything outside the traditional boundaries of Aristotelian narrow-mindedness is wicked and abominable. You may advance, reinforced by one partisan. He was very keen that he should be seen to be publicly supportive of Galileo, which was huge at the time. And he was particularly fascinated by the observations of the moon. He had heard rumor of the discovery of the moons of Jupiter previously, and had been worried that they were actually things orbiting other stars. Bruno, of course, had just recently been burned at the stake for suggesting that the idea that there are planets orbiting other stars, and Kepler wasn't actually comfortable with that idea either. So his only comment on the moons of Jupiter really is that he is incredibly relieved that they're orbiting Jupiter and not another star. Most of his words are actually kept for the observations of the moon, the bit that we don't really talk about. And this is because of the work he had started previously as a student, where he was imagining what the inhabitants of the moon might look like. I forgot to say that I mentioned that Kepler had changed his mind about the bright and dark spots on the moon. He had actually previously thought that the light spots had to be water. And this was based on his everyday observation that when he was on a mountain looking down at a river, that the river glistened and that the land looked dark. So not a crazy idea, but he said to Galileo, "You have proved your point completely. I admit that the spots are seas. I admit that the bright areas are land." He then goes a bit off on a tangent and goes on a long digression about supposing that there are living beings on the moon. Surely stands to reason that the inhabitants express the character of their dwelling place, which has much bigger mountains and valleys than our Earth has. Consequently, being endowed with very massive bodies, this idea that lunar Martians were much bigger than life on Earth again. They also construct gigantic projects. And he goes on to talk about what kind of buildings these moon aliens might have and about their agriculture. It's very off the rails. He's also not at all immune to the old curse of anyone who was given a talk at an astronomy conference and has had some old guy at the back say, "Well, if you read my paper from 1972," Kepler also wrote to Galileo, "Pages 252 and 302 of my book could have told you about this air on the moon." Yes, quite. Anyway, Kepler then went on to turn his previous student dissertation into this book, Kepler's Somnium, or The Dream. So this is what started as his dissertation, imagining what life on Earth would look like to inhabitants of the moon. He finished the initial draft just before he got these observations from Galileo. And this possibly explains why he was so effusive about the observations of the moon in particular and went off on wild tangents about aliens on the moon. He didn't publish this at the time, though. Was probably afraid that people wouldn't take it terribly seriously. But it was leaked in 1611 and then kind of circulated by rumor. And this actually turned into a really horribly tragic story. People believed that it was autobiographical, which he kind of brought on himself because Tycho Brahe is mentioned in this. And the astronomy student who has this dream about going to the moon is a student of Tycho Brahe. Everyone knew, of course, that Kepler had worked for Tycho. The student in the story had a mother who was a herb doctor. Kepler's mother was a herb doctor. And the mother in the story was a witch. So this led to Kepler's mother, Katharina Kepler, actually being arrested for witchcraft. The story goes that this story had been circulating kind of by rumor, and that a local barber's sister called Ursula had a bit of a bone to pick with Katharina Kepler. She had confided in Katharina that she was pregnant by a man who was not her husband. Katharina really sucked at keeping secrets, and this got out. So to kind of keep the scandal at bay, Ursula had an abortion, which was a really horrible procedure in those days. And so to cover up how ill she was, she claimed that Katharina Kepler had put a spell on her. And then in a kind of test case of superstition and confirmation bias, a whole flurry of people suddenly came forward wanting to attribute their various ailments to interactions with Katharina Kepler. So she was arrested for witchcraft, held in prison for years, Kepler spent about 6 years. He defended her himself, like trying to free her while she was being, imprisoned in a freezing cold prison and threatened with torture. He did eventually succeed in freeing her. In the meantime, completely unrelated, his first wife and 2 of his children died. Really, really horrible time. He did get his mother out, and then she died shortly afterwards, probably from spending a winter in a freezing prison. So not a very pleasant story, quite a tumultuous life. But one thing that's really interesting, and kind of the reason that I tell that story, is that while his mother was being imprisoned, Kepler released his writing on the harmony of the world, which is the one where he said that the earth was singing about misery and famine and all that nonsense. It also had his third law of planetary motion, by the way. It wasn't all nonsense. There was some great stuff in there, in between the nonsense. But one other thing that he wrote in there was he was looking at the problems that his mother had faced, and he said that the only difference that he could see between himself and his mother was that he had been educated and she had not, and that the only difference really between the sexes was that one got educated and the other didn't, and that was quite ahead of his time, really, for the 17th century. His mother was died around 1619. And after that, Kepler came back to this book, his Dream. He originally intended to publish it alongside translations of some of the things I mentioned earlier, Plutarch and Lucian. So was quite open about owing a lot to that work and being inspired a lot by it. But he became very, very obsessed with not wanting anyone to read too much into the superstition-y bits of his story. And so he started annotating it like crazy. Between 1620 and 1630, which is when he died, he added so many annotations that there are actually more annotations than there are story now. He talked a lot about heliocentrism, the idea of the sun as the center of the solar system, about the moon being terrestrial, about the nature of gravity. There's also some quite advanced thinking in there about space travel. He gets over the space travel with a kind of hand-wavy magic thing, but he does talk about how in order to get to the moon, you have to overcome the Earth's gravity. But then once you've escaped the Earth's gravity, that hardly any force would be needed to keep you in motion. Sounds obvious now, but this is decades before Newton's first law of motion. So one of the footnotes that Kepler added in his obsessive footnoting was, everyone says it is plain that the stars go around the Earth while the Earth remains still. I say that it is plain to the eyes of the lunar people that our Earth, which is their vulva, this is what they're revolving around, goes around while their moon is still. If it be said that the lunatic perceptions, that's lunatic as in inhabitants of the moon, of my moon dwellers are deceived, I retort with equal justice that the terrestrial senses of the earth dwellers are devoid of reason. So this is the entire intention behind this book is to show, see, if the people who live on the moon can believe that they're stationary, why are we not just as delusional for thinking that the earth is stationary? And so I would argue that this is the first work of real, hard science fiction, that it contains scientific ideas and that it makes points through being fictionalized. It wasn't published during Kepler's lifetime. He died in 1630. This was published in 1634. And there was something of an explosion around this time because of all the advances in science, in science fiction of this kind. So I mentioned before this True Story by Lucian. This was reprinted, as were all these other works which centered on traveling to the moon, all reprinted in 1634, the same year that Kepler's Somnium was published, and were followed in the next few years by The Man in the Moon by Godwin and The Discovery of a World in the Moon by John Wilkins in 1638. So all of this sort of interest in science fiction surrounding the moon was triggered by the advances that were going on in science at the time. showing that developments in science have a huge impact on works of science fiction, and that people use science fiction to kind of explore some of the uncertainties and implications of new developments in science. And it goes the other way too. Of course, a lot of people get interested in science by starting out in science fiction. That's certainly what I did. And so you get things like Jules Verne, who wrote From the Earth to the Moon, among other things, talked about Kepler. He had definitely read Kepler's Somnium. And if you have read From the Earth to the Moon, you may be familiar with the spaceship Columbiad. And so 100 years later, when we were actually going to the moon, the command module of Apollo 11 was named Columbia. There's actually quite a lot of similarities between Jules Verne and the actual Apollo mission a century later, in terms of amount of time it took, the weight of the capsules and everything. This is not at all a coincidence. Jules Verne did actually sit down and do the maths. So Kepler was a scientist who was inspired to write fiction. But we can also look at people who were primarily fiction writers whose work was influenced by science. And obviously there are many of these, but I'm going to stray away from the obvious, and we're going to go to Middle-earth. This is the fictional setting for the works of J.R.R. Tolkien. And here I have to acknowledge Christine Larson, who was, she's an astronomer in the States, who was actually who got me interested, not just in this topic, but actually in astronomy as a whole. I used to be an accountant, and I was treasurer of the Tolkien Society when we ran Tolkien 2005 to celebrate the 50th anniversary of Lord of the Rings. And Christine Larson came over and gave a talk about astronomy and Tolkien, and I quit my job a few weeks later and went and studied astronomy and eventually got a PhD. And that's how I ended up doing things like this. So huge acknowledgement to Christine. So she was the one who introduced me to this idea that Tolkien was actually very obsessed with the internal consistency of his work. Obviously, we know that, but I mean from a scientific point of view. If you're not familiar with the kind of creation myths in Tolkien, the creation myth is covered in the Ainulindale, which is in the Silmarillion. And the idea behind creation is that the universe was sung into being, essentially. It was created by music. And if that reminds you of what we discussed earlier with Kepler and his harmony of the world, that's probably not a coincidence. Tolkien was particularly concerned about phases of the moon. So here the moon is going to come up again. If you look through his published letters, and we're fortunate to have access to lots of previous drafts of The Lord of the Rings, thanks to the work of his son Christopher, you can see through his successive drafts and in his letters that he was very concerned with that the phases of the moon within The Lord of the Rings match up. And he actually reworked the entire chronology of the story to make them consistent so that people were not seeing different phases of the moon at the same time. We're not seeing moons rising at the wrong time of night and that sort of thing. So he actually took this very seriously. And if you've ever seen any of my talks on astronomy in movies, you'll know that Hollywood does not take this as seriously at all. So huge kudos to Tolkien for that. So brief introduction to the cosmology of Tolkien's world. If you're not familiar with it, you might not know that it started off flat. Tolkien was a flat earther, not really. So the idea was in the first age of Arda, this is the world, the whole world was flat. So on this map, what you're looking at, I don't know if you can see my cursor on this system, but just in case, up here, Beleriand is kind of the area where the Lord of the Rings takes place. And the area over to the left, so in the west of this world, is Valinor. This is kind of the realm of the gods. There was also, at some point, I think in the Second Age, an island called Numenor, which is kind of here in the kind of semi-Atlantic Ocean. which was raised up for men to live on. But then they pissed off God, and so the world was broken. It was kind of bent or made round, so that we now have a round Earth. And Middle Earth is supposed to be on Earth. Tolkien acknowledged he hadn't paid any attention to getting the geography of continents right, but it is supposed to be Earth in the very, very distant past. So we now have a round Earth, but this kind of western region of Valinor is still off kind of in space, I guess, and is accessible by this straight road. So you can imagine you had this kind of flat Earth, and it's just been bent away, but you can still get to that bit by this straight road that only the elves can cross. Or if you read the appendices of Lord of the Rings, 3 hobbits and a dwarf later on. Tolkien actually said in a letter in 1954, so this was before the publication of Return of the King, "So deep was the impression made by astronomy on me that I do not think I could deal with or imaginatively conceive a flat world." So the change to the Earth is part of the kind of cosmology within the mythology of his universe, but he did it because he didn't really like the flat Earth thing. He wanted it to make sense scientifically. So let's talk about the moon and the sun in Tolkien's universe. In his mythology, the sun and the moon came from the last flower of the 2 trees of Valinor, which are represented here on the Tolkien Society logo. The idea is that they were poisoned by Melkor, and that the golden tree gave one last fruit and the silver tree gave one last flower, and these were cast into the sky and became the moon and the sun. So this is obviously all very mythological. But the thing that's interesting is how Tolkien kept adapting and reworking this story and some of the details that he put in to try and kind of make it sciencey. So if we talk first about the moon came from a flower that fell from the tree. And so in some of his writings that were published later by his son Christopher, he says some of its dewy light was roughly shaken from it, and here and there a petal was crushed and tarnished. Despite its hurts, its glory and fragrance and pale magic were very great indeed. The idea is that the flower fell, it got kind of bruised and battered, and this is why the moon has all these dark spots. So they're not seas, they're now bruises on the flower that became the moon. So I'm going to use some fan art here just because it's really pretty. This is by Breath Art on DeviantArt. So we had this like fruit and this flower that were cast up to be the moon and the sun. And these 2 Maya, these are like not quite God. Are they considered gods? Don't know. I don't spend a lot of time discussing Tolkien with people. Tilion and Arion were tasked with guiding the moon and sun, respectively. The idea originally was that they were going to be in the sky together, and that they travel from west to east. And this means that there would always be both the moon and the sun in the sky. But Tilion, who was driving the moon, was a bit of an erratic driver and was kept being drawn to the splendor of the sun. And when he got too close to the sun, his vessel would be scorched and blackened. So it was decreed that only one of them could be in the sky at any one time, and they would go underneath the earth with every setting and rising. But Tilion, this is the moon, is still being constantly drawn towards the sun, and this is why sometimes both of them are seen in the sky together. And there is this piece where Melkor assailed Tilion, sending spirits of shadow against him, and there was strife beneath the pass of the stars, and Tilion was the victor, as he ever yet hath been, though still the pursuing darkness overtakes him at whiles, which is probably an explanation for lunar eclipses. Here's a lunar eclipse. So in this, even though it's a very kind of fantastical mythology, we've got an explanation for the phases of the moon, that the moon keeps getting closer and closer and closer to the sun. We have eclipses when the moon gets scorched by getting scorched and blackened is the phrasing, by being too close to the sun. And we have this being assailed by Melkor every so often, turning the moon red to explain lunar eclipses, which is quite a lot of science to go into such a fantastical mythology. So in some of the previous drafts that were published later by Christopher Tolkien, we can actually see that Tolkien kept reworking the Ainul Indale. This is the creation myth, before ending up at the version that was published in the Silmarillion. And some of the other versions that he published are really interesting for what they reveal about his different thinking about how the universe was created. So at the time that Tolkien was writing, we didn't really know how the moon was formed. And there were three main theories. One was the theory that it formed at the same time as the rest of the solar system. So you've got this big nebula, big cloud of gas and dust, that it all collapsed down, and you've got the sun, the planets, and the moon all at one time. There's the capture theory, which is that the moon was created separately from the Earth, but that at some point it flew past and got captured into orbit. This is a bit problematic because it needs to have slowed down at exactly the right time. And there was this fission theory, the idea that the moon was once part of the Earth, and that the Earth, when it was molten, kind of a bit of it split off. And the reason I mention this is that this is one of the other drafts of the Ainul Indale. Melkor is very upset, and he says, when the earth is hot and fiery, I will rend the earth asunder and break it, and none shall possess it. And it goes on, but this Melkor could not do, for the earth may not be wholly destroyed against its fate. Nevertheless, Melkor took a portion of it and seized it for his own and reft it away, and he made it a little earth of his own, and it wheeled round about in the sky, following the greater earth wheresoever it went, so that Melkor could observe thence all that happened below, and could send forth his malice and trouble. And it goes on to say that this became what men call the moon. So this particular draft of the Ainul Indale is particularly striking because in this version, the Earth was always round. And it's said that Tolkien actually sent both drafts of this, the flat Earth version and the round Earth version, to someone, asked their opinion, and they said, I like the flat Earth version better, and that's why it ended up like that. But he did have this alternative model in which the Earth was round. So it was some time later that the giant impact hypothesis was put forward. This kind of followed on from the Apollo missions when we had more knowledge about what the moon was made of. And so by the mid-1970s, we kind of settled on this idea that the moon was actually formed when another kind of Mars-sized asteroid crashed into the Earth and split a little bit of it off that became the moon. This, unfortunately, Tolkien died in 1973, so we'll never get to see the version of the Ainul Indale with the giant impact hypothesis. But it's very interesting that Tolkien was clearly very invested in the science of his world. And I have to refer you back to Christine Larson, who I mentioned at the beginning of this bit, who has written extensively on how Tolkien's successive drafts showed that he was kind of keeping up with the scientific developments of the time. And even suggests that one of the things that stopped him ever publishing the Silmarillion, of course, it wasn't published until after his death by his son, was that he was very troubled by it not being very scientifically accurate. And he was very concerned that people not think his character's stupid for believing all this, that it was important people understand they don't necessarily believe it literally, and it should be consistent with actual cosmology. And I think it's very interesting that he was so concerned by that. Particularly if you were at TitanCon last year and saw my talk about another work of fantasy and the thought or not that went into its cosmology. Anyway, so this has been a bit of a whirlwind tour of two of my favourite people from history, but I hope you found it a bit interesting to contemplate the science fiction writer Johannes Kepler and the astronomer J.R.R. Tolkien. I do need to finish in my last couple of minutes with a bit of a shameless plug. When I'm not thinking about science or science fiction, I also run conventions. And one of the conventions I run is called the Ineffable Con, which, like a lot of other things, went online for the first time this year. And we had more than 650 people show up for my very first time running a virtual convention. And it actually went really well, spoiler alert, which is surprising. And I'm giving a talk tomorrow about what I learned from that experience and what I think about virtual conventions in general, which might be of interest to some people here. It's tomorrow at the imaginatively titled Virtual Con, 6 p.m. GMT tomorrow night, Sunday, November 15th, at virtualconcon.cu, CYOU, that is. Of course, some of you may be busy with this other convention at that time, but the recording is going to be available from that website afterwards if that's something that you're interested in. Right. So that's it. Thank you very much for coming. And I don't know if I have any questions. Is John going to tell me?
Thank you very much.
Hello.
Yes. So we will post a link to Rachel's recording from the other convention in the newsletter at the end of punctuation for anyone who does miss it. We don't have any questions yet. I think people were enraptured because we also didn't have anyone bickering in the chat, which is different to some of the other items I've seen. So I think you captured people's attention. I did have one question, which is, we've got people saying thank you in the Discord. So Russell and Simon and Nicholas are all saying thank you. So do you think, talking about Tolkien, like, do you think he was prescient, like, or do you think that was based in kind of his readings, or do you think he just sort of happened upon something with his kind of theories about?
No, I think he was like generally a very well-read dude, and I think was kind of aware of what the scientific thinking was at the time, and I was constantly trying to work that into his universe.
Fair enough. We have a lot more people saying thank you. So Helena and Dave and Johnny and Claudia and Graham and Shona all say thank you. And in the YouTube chat, Vicky says thank you, interesting. But yeah, it was a fantastic talk. I'm very sad I wasn't at TysonCon to hear your Game of Thrones talk. I don't suppose you've done that at any virtual conventions that happen to have recorded it?
I have not, but I do still have it if anyone would like it. I'm actually not that negative about it. I really like being given a problem and being like forced to come up with a scientific explanation for it. I think that's fun. I don't think anyone is under the illusion that George R.R. Martin had that in mind when he wrote it.
Shocking. So Dave asks, is there any evidence that Tolkien had talked to the astronomers at Oxford when he was there?
Oh, not that I know of, but possibly they exist.
That's fair. What's the work that you found it hardest to reconcile with scientific reality in your kind of, because I know that you've done kind of
Game of
Thrones and Star Trek, and
it depends. I mean, a lot of things obviously aren't even really trying. So I think the ones that I struggle with are the ones where they clearly are interested and still get things horrendously wrong. But yeah, I don't think it's very interesting to read books or watch films and just say, "Oh, well, that's wrong. That's wrong." I don't find that fun. What I find fun is to say, "Well, this clearly happened because it's here written, or I've seen it on screen. So how do I explain that?" I think that's a lot more interesting. People are very fond of ragging on the film Gravity. I actually quite like it. I think it's a good film. And the one bit that is quite egregiously wrong involves the death of a character that I was finding really obnoxious anyway, so I'm not that bothered.
Excellent. Fair enough. And if I recall correctly, you did a Star Trek blog where you did the science of original series Star Trek episodes.
Yeah, which is actually like surprisingly good. Like, there are things in the original series where they're actually discussing things that were big problems in astronomy at the time, and like quasars is the one that comes to mind. They're very they have standing orders to investigate any quasar-like phenomenon because that was really mysterious in the 1960s. Today, of course, that makes no sense because we know that quasars are not in this galaxy and the Enterprise cannot travel outside of this galaxy. So, like, with the benefit of hindsight, it's garbage, but like, at the time, that was interesting. And yeah, a lot of I think you just have to accept like warp drive and transporter beams because they're necessary for the plot. And once you strip those away, a lot of the other stuff is actually pretty good.
Cool. Well, thank you very much again for a fantastic talk. If anyone has missed it, there will be a link that they can watch it on, which will obviously, if you're kind of coming in now, I apologize, but the link will be posted in the newsletter. But yeah, thank you very much for talking to us.
Right.
And
thank you very much for having me. And
no
have
worries.
a great convention.